Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast. We look at application development and management at scale. Sysdig is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Sysdig's perspectives on these timely and important subjects in our latest ebook about management and monitoring in the Docker and container world. The ebook is available for download at thenewstack.io. Now let's get to the show. Hey, it's Alex Williams, the New Stack, here for another episode of the New Stack Analyst. Today we are talking about monitoring with Loris Degioanni, founder of Sysdig and the creator of the popular open source tool by the same name. Hello, Loris. How are you?
I'm great, and good morning.
Good morning and good afternoon to you, because you are doing this interview from your vacation in Italy.
Yeah, from a beautiful village in the Italian Alps.
Yeah, I remember our conversations about skiing in those Alps and stuff, and like the beauty there. And so hope you're enjoying that. Loris, I want to thank Sysdig very much for being a sponsor of our ebook series on Docker container ecosystem. The fifth book is about monitoring. I think it's going to be one of the most interesting books that we do. I'm looking forward to this conversation here, where we're going to talk about monitoring and some of, I think, the intricacies of it and how it really reflects the changing architectures that we see. We're also joined by Ben Ball, a co-anchor for this episode of the New Stack Analyst. Hey, Ben, how are you?
Hey, how's it going?
Great. And Ben manages the overall strategy and production and direction of our ebooks. And so, Ben, thank you for joining us.
Always good to be here, and great to talk to Sysdig about this topic, because this is something we're thinking a lot about for the upcoming book.
Great. Loris, why don't we just get started? Why don't you just tell us a little bit about Sysdig and your own background, because you also were the creator of Wireshark, and tell us about the story that you like to tell about why you decided to start Sysdig, and providing some context about what Wireshark as well.
Let's see, where should I start? When I was in kindergarten, no, that's too far back in the past. I've been involved in open source and application and network monitoring for many years now. As you were saying, I've also been involved in the Wireshark project since quite early on, especially from the packet capture side, having built a popular open source packet capture library called WinPickup. And I was very excited and very interested about the new waves coming into IT. Especially my background was in network level visibility. My company was acquired by Riverbed, where I spent quite a bit of time working on monitoring visibility from the network side. And I quickly realized that vintage points that we traditionally used to analyze application performance and infrastructure performance, like, for example, network spam ports, router spam ports, or network taps, were not available anymore, because the network in a heavily virtualized or cloud or containerized environment doesn't really exist anymore as a vintage point, because there are layers of virtualization both at the operating system and the network layer. So I started wondering, how do we solve the visibility problem for modern infrastructures? Because I was fully aware that the tools that I had built multiple times in my career were not available to accomplish that. And so I embarked into creating a new technology from the ground up that would be designed for visibility into modern infrastructure. So infrastructures that are heavily orchestrated, microservice-based, container-based, and I started focusing together with the Sysdig team on the challenges of monitoring these infrastructures. And there are many challenges. Some are technical, some are just maybe based on how teams are organized, in modern infrastructures. Sysdig was started in 2013, and we spent quite a bit of time developing our core technology, which is offered both as an open source tool, open source Sysdig, and as a distributed end-to-end monitoring and visibility tool that can be consumed both as a cloud product or as an on-prem solution, and this is Sysdig Cloud. And essentially, we're really trying to have a product that is heavily focused and designed for the new way of doing IT.
I think that sums up kind of the market pretty well right now, where, traditional monitoring, assumes, for example, that a host or a service is very long lived. And, now we're kind of in this new world where containers, appear, they disappear, they can be, they're very ephemeral, as people like to say. I'm curious, on your philosophy about this new architecture and how that's reflected in what you're offering at Sysdig.
Yeah, there are a couple of implications. First of all, what you say is completely exactly right. And we are really seeing among our users really intense and advanced workloads in which containers are spawned at this point not only maybe every few seconds, but really sometimes for every single request. So we routinely see users that have maybe thousands or tens of thousands or sometimes millions of containers in a matter of few days or a couple of weeks, something like that. So that, as you can imagine, tends to break the traditional monitoring workloads, and there's a couple of implications. Implication number one is a lot of what's happening is below the sampling ability of your average tool, right? So not only is challenging to collect the metrics for an entity that lasts only maybe a few milliseconds or a few seconds in the best case, but it's even hard to see that entity was there, and that it existed. So from the monitoring point of view, let alone collecting detailed metrics, just knowing that a specific container was there and did something at a specific point in time is becoming challenging, because the typical sampling time and reaction time of a monitoring tool is in the best case the minute, or maybe even higher than that. So the whole landscape is really revolution quite dramatically by this. And the other implication, in my opinion, is that the single container becomes important because you need the data, but it's only important if it's the data coming from it, the metrics coming from it, are put in a broader context, in the context of the orchestrator, in the context of the service. Typically, containers go up and down because there's something like I don't know, Docker Swarm or Kubernetes or Mesos that orchestrate them and create new ones and destroy the ones that are not used anymore, and so on. So typically, what you want to see is in the context of the service, of the application, of what containers cooperate to create, implement, and deliver. And without that kind of context, you are just inundated by an overwhelming amount of metrics that don't really have real usefulness for you.
Mm-hmm.
Loris, I have a question. So it sounds like Sysdig was kind of built for these dynamic and changing environments. My question is about microservices and containers, or rather microservices as a pattern for containers, containers as a way of enabling microservices. Were these both considerations when Sysdig was created, or are they kind of part of the same concern?
They are definitely, in my opinion, the two sides of the same coin. So first of all, at the high level, I think that nowadays it's going to be harder and harder to separate containers from microservices. Not because containers cannot be implemented, not because microservices cannot be implemented with containers. That's absolutely possible, but containers really are the perfect technology, to implement them. Some, basic technical decisions behind something like Docker, like, containers are very simple. They need to be very small. They are lightweight. Typically, they run just a single process. Made them really the perfect building block for microservices. At the same time, managing something like Docker that really promises you, in the long term to make it possible to create much more complex infrastructure by essentially composing pieces, delivers this promise only if you have something on top of that can, break these into entities that are more manageable, like services, and then as a scheduler like Kubernetes or Mesos or Swarm and so on. So in terms of us as a company, definitely this kind of separation that I just described, but this complementary separation also tends to reflect our technology and our technical approach pretty well, because the two core pillars of our technology are number one, ContainerVision, which is the ability to see inside containers through a bunch of patent pending technologies that make it possible to essentially inspect what's happening inside a container, even without installing agents inside the container. And that essentially tries to support visibility for Docker and for containers specifically. And then we have essentially workless and patent pending interaction with all of the major schedulers to essentially take this information and correlate it at a service level. So these are really the two pillars on top of which we build our solutions, our open source solutions, and our commercial solutions. And for us, it's really, one doesn't really work without the other one.
So tell us a little bit more about ContainerVision then, and what and its role here, and how. And then if you could provide some context, it'd be great. So like, how does ContainerVision differ from the more traditional monitoring solutions that we see in the market that were developed really for an age where, like, again, like we talked about at the beginning of this program, where, just the architecture entirely different, running for much longer, designed to run for much longer times, whereas opposed to containers are, much more ephemeral.
Yeah, as I was saying before, typically the traditional approach to monitoring in the physical and virtual world involves either doing some kind of remote checks, for example using the network, or doing some kind of polling like SNMP or WMI. So essentially you can go and query something coming out of the machine through standard protocols, or even more typical, especially in case of virtual machines or cloud computing, by running an agent. An agent inside every physical machine and every virtual machine. This works very well, for example, with cloud computing, where essentially what you do is you run virtual machines on hardware that is rented in quotes from Amazon or Google or Microsoft or other cloud providers. Now, this approach works very well for virtual machines or for cloud instances, because these are like full machines, like a cloud instance is a full version of typically Linux, where you have an operating system kernel running, and you have the full operating system deployed in the machine. So it's quite easy to just add a little overhead in terms of an agent that just runs as a process in the machine, or that you link to your application or something like that. Containers are sometimes compared to lightweight virtual machines, but in practice, containers want to be much smaller. When you run a container, it shares typically the kernel with other containers running on the same machine, and this makes the containers much more efficient and easier to pack to accomplish higher density. Containers also typically just include a single process and the bare minimum set of dependencies to run that process, which means that running something else inside the container tends to be challenging because you don't have a full operating system there, because you don't have all of the libraries and dependencies that you need to run your monitoring scripts or your monitoring processes, and because typically you want to pack many more inside the same machine, so making them bigger and adding hundreds of megabytes of dependencies just because you need to run like Python or Java to see what's happening inside the container and what applications inside the container are doing is unacceptable. So there are a couple of solutions. One is leveraging well-known APIs exported, for example, by Docker. Docker is a Docker Stats API, and you can use this API to gather some metrics from the containers. That's very useful. On the other hand, it tends to be relatively shallow because Docker just gives a handful of metrics for each containers, overall CPU utilization, memory and disk and so on. But what you really care is what's running inside the container. The other solution is our ContainerVision. ContainerVision works by essentially through a couple of different techniques. The main one is installing a module in the operating system, and this module is deployed transparently when you run the Sysdig container. So the final user just needs to do a Docker run Sysdig or use the orchestrator to make sure that Sysdig runs on the machine, and the Sysdig container is able to instrument the operating system and start the collection of metrics that happens at this point underneath the container. So instead of having to put something inside the container, you put something underneath the container. And the advantage is that installing this is completely straightforward, completely horizontal. So you never forget anything because this module sees every single container, including the ones that are running down, including the ones that will run in the future. And that's one of the way we manage to see everything. Before I was saying, when a container lives only for a fraction of a second, you could really miss it completely. You don't even know that the container ran. But if you're sitting in the operating system, you see when this container starts, and you're ready to collect the metrics immediately. Really, that nanosecond when the container goes up, and then you see everything, and you see the application, the process that is running inside the container, and you're able to essentially run checks that get data for this process or this application. For example, SQL queries or response times and this kind of stuff in a way that is completely transparent and really doesn't require any instrumentation of the application or any instrumentation of the container. The result is that you have a very straightforward way to deploy monitoring. Sometimes we call it monitoring as a microservice, because by just running the Sysdig container, you're good to go and you get your metrics flowing. So the plumbing is very straightforward, and that's very important because when you have applications going up and down continuously, you cannot, you spend resources to just configure these applications to make sure that you have monitoring. And the other consequence of this is that you are able to see at a very, very deep level of granularity.
So I have just a quick follow-up question. When you say, Sysdig kind of operates by working underneath, can you explain that, what you mean by that? And, how does it work? How do you get underneath, to be able to do what you guys are able to do in terms of collecting all those metrics and such?
Yeah, we leverage some interfaces in the Linux kernel, and I'm going to become a bit more technical here. Yeah. I hope it's okay. But yeah. We essentially collect events that the Linux kernel is producing when things happen on top of the operating system. So when applications run, in particular, we capture interactions like system calls. So every time a process is interacting with the machine hardware, with the operating system, a system call is produced. A system call, for example, is done when a file is open, or when data is read or written, or when a network connection is established, or when a server receives a connection, or when there's a data exchange on the network. So, or when a process is created. So all of this information we are able to collect it really at the micro granular level, which means that we're able to essentially reconstruct the life of applications running on a machine, really at the single file open or network communication, network connection, or network data payload level. We get this information, we collect it, and then we have a quite sophisticated functionality to decode this information, so that, for example, if this data is a query to a MongoDB database, we see it, we intercept it, we decode the content, we are able to understand the context. So, for example, what query or which collection is involved, and then we're able to automatically get these metrics to a centralized place so that you can run essentially reports and dashboards and set alerts on top of this.
So I'm curious, so if you have access to that, that interface, and you can get all these deep metrics, what is the security environment that you set up? Because that's some pretty deep access, into the kernel itself.
Yeah, our container does require privileged, needs to be granted essentially privileged capabilities to get this kind of data, which can potentially be a concern. On the other hand, if you think about that, there are also benefits with this approach, because typically the alternative is heavily instrumenting each container so that you're able to gather data out of them. And essentially doing that means adding processes and adding dependencies to your containers, which are actually implementing your actual services and have, exposed surface to the external world. With our approach, your containers are absolutely completely clean. You can get them from the Docker Hub, you can run them without any kind of modification, and you need an NGINX container. It will run only NGINX and nothing else, and there will be no additional libraries, no additional processes, no additional ports it's listening in. It's really completely clean, because what happens is the data is captured from the underneath and goes to our container. Our container, which is, of course, completely sealed from the external world and is only an outgoing connection to the backend, which can be, by the way, optionally inside your own infrastructure. So our container has all of the dependencies. It runs, Java to query Java applications and Python to run scripts and a C compiler to be able to install the proper kernel module and all of this kind of stuff. But all of this is isolated from the containers that actually run the application. So we manage essentially to push all of the potentially dangerous dependencies to a separate isolated place. And of course, we take all of the possible precautions internally to make this container as safe as possible. By the way, one of the reasons why our core technologies is open source is because we have a very big community deploying this in the open source, and we also get tested and reviewed for vulnerabilities by the community and by the main distribution maintainers. And also, externally, we try to play as nice as possible with all of the entities involved in the container ecosystem, including being certified, being scanned by the different players, Red Hat and other entities, and trying to be as scrutinized as possible by the community and by the vendor ecosystem.
Now let's take a quick break before we get back to the second half of the show. Sysdig is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Sysdig's perspectives on these timely and important subjects in our latest ebook about management and monitoring in the Docker and container world. The ebook is available for download at thenewstack.io. Now let's get back to the show.
So I have a question, Loris. We talk quite a bit about, at the New Stack especially, container orchestration and how really that kind of changes the way that a lot of even these kind of early container products approach what they do. And we released a book most recently about automation orchestration. So I was wondering, has the container monitoring landscape and really what you guys do at Sysdig, is that changed at all by orchestrators like Docker Swarm, Kubernetes, and Mesos? Or is it a matter of scale of what you're already doing?
The answer is yes, it's being changed a lot. Let me start by saying that orchestration, in my opinion, is really the revolutionary piece here. I mean, the container runtime is absolutely important and it's great, but it's more like the big value that the container runtime like Docker brings is having the world agree on a standard to package your containers, right? And to run them, and that's great. But taking this standard and taking these containers and orchestrating them into microservices by using Docker or Mesos or Swarm is really what has the potential to revolution the way we build and we run our applications. Now, of course, from the monitoring point of view, this is a major revolution, even bigger than collecting data for containers. So seeing inside containers is challenging. I was describing, our solution to that, and is definitely very important. But monitoring orchestrated containers, or let's call them microservices for simplicity, is a whole new set of challenges, because you put the opaqueness together with the complete fluidity and arbitrary allocation of your application components. Now, the reason why I think it's really revolutionary and really powerful, it's because there's also a lot of potential there. I truly believe that something like Kubernetes or Mesos really have the potential not only to get good monitoring, but really to make monitoring and visibility and observation better. Observation becomes more and more important, but at this point, it needs to be done in the context of the orchestrator. So you need to understand what a service is, you need to understand what a task is, you need to understand what a replication controller or a replica set is, and you need to expose data in that context. You need, for example, what we do is we consume the Kubernetes or Mesos APIs, and we are able to reconstruct the hierarchy and the organization of services. And we put the metrics together in our backend so that you can make queries like I want the response time for my front end in the last 2 hours. And that front end can be made up, of 20 containers that are running on 16 different physical machines. And it doesn't matter, because we find these containers through the tags. We understand that they are part of the front end service. We get the response time for each of them, we average it, and then we show it to you over time. So this kind of stuff can really be, automated if you consume the orchestrator API as a good citizen. And doing that is really the only way, in our opinion, to monitor something like Kubernetes or Mesos and so on. Now, there's even more potential here, because what you can do is leverage, for example, most of these frameworks allow you to annotate your services, right? So we are working, and we are releasing features that let you specify the kind of monitoring that you want for your service by using annotations. So when you create your service, for example, in Kubernetes, you can say, this service is a production service, and I need alerts on CPU and response time for the service, and I would like the alerts to go to this specific person, and we are able to interpret it and configure monitoring automatically based on what you configure in your service, so you don't even have to go inside our tool. In particular, a very powerful feature that we are close to release in our product is orchestrator aware multi-tenancy. So we are able to offer in our product not only a complete end-to-end vision on your infrastructure, but also some specific views on services that are maybe owned by a specific team. And we can offer specific login for the team, and the team can configure their own dashboards, their own alerts, their own alert recipients, their own views or whatever they want, and they can do that at the orchestrator level, and we understand it, and essentially we create automatically this sort of mini monitoring environment for the team with all of the information that is specific for that unique team.
A lot of what you're talking about here requires a lot of, measurement of data, right? Where like and a lot of what you're talking about here means that you've really got to think about not just the container, but, you're looking, at the overall microservice. You need to think about a lot of different factors where it really seems to me that you're starting to think more about telemetry issues more than anything else. Is that accurate?
Yeah, and typically telemetry has two aspects. One is getting the data that you need,
right?
And the other one is getting the insights that you need from this data, right? Both of them are very tough and extremely interesting challenges for containers and microservices. They are sort of, again, orthogonal, but also one is required for the other one. And again, yes, that's what our products, both the open source one and the commercial one, tend to focus on. Yeah.
So that leads to a question then about overall infrastructures that we're starting to see emerge, where they're increasingly have to be designed for scaled out systems and scaled out applications that can scale out very, very quickly. And we've been doing that with, virtualization really up until quite recently, until really the advent of Docker and such. So, for many years, but applications did not have to scale, right? You'd have, these systems of record inside, that operate inside the enterprise. And a lot of the tools that were developed for those frameworks are now trying to adapt, right, to this new kind of a world, right? How do you guys kind of think about yourself inside, this kind of new world where we are starting to move out to these scaled out applications, but there are still out these legacy environments out there that are still there, and you have these tools that are built for those, but they're also trying to adapt into this new market. So it's almost like you're forging ahead with something very new and very modern, yet there's a lot of existing stuff out there that you have to consider, a lot of tool vendors out there that are catering to them.
That is absolutely the case. So, by the way, what I'm seeing overall happening in the industry is it's really surprising how much even, let's say, more traditional enterprises are picking up usage of containers, of microservices, orchestration, and really, starting using this technology. So they are really adopted extremely quickly, not only by leading edge companies, but also by more traditional, let's say, players. At the same time, clearly, there are very different ranges of experimentation here, right? So some people are all in with, Docker and Mesos or Kubernetes and so on, but more typically you have hybrid approaches in which, especially, bigger enterprises, maybe they have a lot of legacy tools and a lot of legacy deployments, and then they are starting gradually, investing into modern infrastructures. Now, from my point of view, this is just an extension of what we're saying, right? If your tools, especially, for example, in our case, the monitoring tools, are good at supporting modern, elastic, flexible infrastructures, they should be also good at supporting the more standard ones, because more than, what I see is enterprises having like computing and computing resources and applications, and you need to be able to follow those applications from essentially physical hardware to Docker containers, no matter where they go. So the approach that we're taking is definitely the one of supporting any possible workload in the best possible way, not only, but also offering a single pane of glass, the famous single pane of glass in which you're able to see both your traditional servers that are running maybe on bare metal and your very modern applications. And the trick for doing that is, again, a very horizontal instrumentation that is able to cover everything. So the kernel module approach that I was showing before, that I was describing before, is designed to see everything, not miss any single piece of data, no matter where it's coming from. Because when you're in the kernel, you can see processes, you can see containers, you can see applications, you can see whatever you want, and then the ability to reason not only in terms of unique resources, but in terms of applications, tags, services, metadata, so that you can easily split and segment this data based on criteria that are both related to, a modern orchestrator or to more like a traditional monolithic approaches. So the user interface that we are trying to design, and that I bet, any modern IT software vendor is trying to design, is something that tries to go across, these different silos and these different areas in the enterprise IT.
So one of the things I try better to understand is how some of these newer products and technologies like Sysdig affect and kind of influence maybe existing products, maybe what we would call legacy products, since we're talking about the legacy environments that they often appeal to. Do you think it's something where, or rather, are existing legacy vendors, maybe older, larger application monitoring vendors, are they adopting some of the techniques that make Sysdig so well suited to microservices environments, or is this something that is kind of still a developing market?
I think it's still a very developing market for the moment, honestly, I see only minor steps from traditional vendors in our direction. I absolutely expect bigger steps to be taken by these vendors, especially by the more, let's say, progressive ones, and the ones that are better at reacting at the market around them. I definitely see, some vendors that are very good at doing this. At the same time, think about that. For example, how many of the legacy enterprise monitoring and management vendors really manage to evolve their products in an effective way for cloud computing? Not many, if you think about that. And cloud computing sort of, created a new set of vendors very specialized in that, and they were able to do just a much better job there, And why is that? That's because typically when you have a shift of the magnitude, you go from servers running in your data center running very static applications to, instances on AWS that are based on a very different premise. You essentially run them by the minute. your tools really need to be rethought from scratch, right? You need to sort of start over from a blank sheet of paper, and that's how a new set of vendors essentially gained prominence in the last few years. We as Sysdig strongly believe and are betting on the fact that the same thing is going to happen with containers. So do I respect the current vendors of legacy, vendors of monitoring tools? Yes. Do I think they can evolve their tools to get somehow there? Yes, but I also think that there is really space for winners that really think this from the beginning and develop a product that is designed from the beginning for this, because otherwise it's always retrofitting, something that is already existing, and you never reach the optimal solution. What we're trying to do here is creating the optimal solution for this specific problem.
How important is the ecosystem around you, for your own success? You mentioned Nginx and different load balancing environments, and there's different platforms and services that that have to really have this integrated capability to make it work for these customers. How important is that for you, and what are you guys doing in light of that?
It's of really critical importance. First of all, as a company, we are fully aware that we will only be successful if the whole ecosystem is successful. If containers and microservices and orchestration and so on are successful. From let's say the pure utility and technical point of view, I have no doubt whatsoever that these kind of technologies have the potential to really revolutionize IT. But of course, in order for this to actually happen, these technologies need a lot of execution, of proper execution.
Mm-hmm.
And a single vendor cannot deliver all of this execution, at least in the short term.
Yeah.
So we need to work together, and we want to work together with all of the other vendors. We try to do that both from the technical point of view, by trying to collaborate with the companies in this ecosystem, both the ones strictly in the container ecosystems like Docker, CoreOS, Mesosphere, and all of the other companies in this space, and with the companies that have to do with like modern infrastructures and modern IT. From the open source point of view, we added support for Docker very early on. We added support for Kubernetes and Mesos and Swarm essentially as like more than a year ago at this point. So as these technologies were really at the beginning, at the early stages of development, and we try to do this in a way that brings benefit to the community, but also can be a valuable asset to the other vendors. In particular, we strongly believe that there are a couple of elements of friction for the modern IT, Docker and microservice-based modern IT to be successful. And security is definitely one of them, and visibility is another one. So by offering a really phenomenal monitoring tool that can address the needs of small companies and enterprises that move to this new world, we also give our contribution to the ecosystem of vendors by essentially decreasing friction to adoption.
I'd love to talk with you more about open source ecosystems and their evolution and how open source ecosystems scale at another time. That's a topic we're really interested in discussing, and we're actually going to be having a series of discussions on this topic. So I look forward to hearing some more from you. Ben, any other thoughts that you'd like to share, or anything else you'd like to ask Loris?
Well, since we're wrapping up, Loris, I was going to ask, essentially, if you had anything else to say, maybe to add to this space about container monitoring, and again, what makes this space so special, and something that maybe I should consider as an editor going forward with our next ebook. What is especially important about this? What is something to keep in mind about this space?
So a couple of things. One is I see, as I was saying before, keep an eye not only on how monitoring is going to catch up, with these new infrastructures, but at how monitoring can become better. In my opinion, there are really opportunities here to make monitoring move forward. Monitoring is sort of been the same, for the last 15 years. And now more than 15 years, 20 years, and it's always been variants of the same, 2 or 3 different techniques. And as I was saying before, now that IT is changing really heavily, I see a lot of opportunities to really not only have equivalent monitoring as we had before, but something better, of sort of rethinking monitoring. And again, we're really working on it in terms of making monitoring easier to deploy. So having, monitoring that is deployed by just running a container, or making monitoring more like team friendly, so that instead of having a giant monolithic monitoring tool, you have something that follows more like the service organization and the orchestration of your containers, and creates like mini monitoring tools, mini monitoring environments that are more like human friendly. The other direction that I see monitoring potentially evolving in an interesting way, and that is part of our core technology, is the ability to sort of add value to your monitoring tool by sort of creating a hybrid between a monitoring tool and a security tool. For example, we experimented in the open source this spring by releasing an open source tool called Falco, which is essentially a behavioral activity monitor built on top of the Sysdig engine. So we leverage the same powerful tricks that I explained before, in particular being able to put a kernel module inside the operating system that sits underneath the container to extract information that is not only, for example, I don't know, the trend of the CPU or the response time of a specific application, but also, I don't know, the anomalous activity of a container, or unauthorized user logins inside a specific part of your infrastructure. From this point of view, another area that I find very promising is extending monitoring for troubleshooting. So there's a lot that our tool can do that is quite novel and quite unique in terms of not only being able to export metrics, make it possible to set alerts on these metrics, create thresholds and the kind of stuff, but also deep dive inside a container to get, the really granular activity of what's happening inside the container, and maybe create trace files that allow you to troubleshoot what was happening in a container that doesn't exist anymore, maybe the following day. And again, we try to leverage the same infrastructure and the same deployment so that we can offer a tool that also has powerful troubleshooting capabilities. And that's again extremely important in something like orchestrated containers, where stuff probably doesn't exist anymore when you want to understand, the fine-grained details of an issue. And even if it still exists, there's not even the possibility to create a shell, because you don't even have maybe, the SSH server, in some of your containers. So this kind of stuff can evolve in ways that are interesting, novel, powerful, and some of them, we've already implemented them inside our product.
Behaviors, they can be so funny, can't they?
They very often are.
Well, listen, Loris, this has been a really good discussion. Thanks for bringing up Falco. That was a topic I did want to address. So that's I think a story that's just beginning on how we deal with the behavior of these monitoring environments when we have container infrastructures. Thank you very much for joining us. Enjoy your vacation there, and we'll see you there. We'll see you soon. Where are you going to be next when you come back from Italy? You going to be at any conferences or anything?
Yeah, probably a bunch of conferences this fall, especially the container-related ones. So
So that will include, I guess, ContainerCon and Mesos Con EU and events like that.
yeah, absolutely.
Great. Well, we'll see you at ContainerCon for sure. So we'll have to sit down and talk. I'd love to talk to you about open source ecosystems. So I look forward to that. And good luck with Sysdig, and we'll talk to you soon.
Thank you. See you soon, and also thank you to our listeners here.
And Ben, thank you for joining us. Appreciate your insights, and we'll be back again soon with another episode of the New Stack Analyst.
Thanks as always.
Take care.
Bye-bye. Sysdig is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Sysdig's perspectives on these timely and important subjects in our latest ebook about management and monitoring in the Docker and container world. The ebook is available for download at thenewstack.io. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.